So we can build up new functions by multiplying a constant onto them. But we could also build up new functions by adding two different functions together. See what we get. We do this all the time. That's how polynomials work. So I want a new rule to tell me how to calculate derivatives of the sum of two different functions, f of x and g of x. Now, granted, both of these functions need to be differentiable, but as long as that's true, and that will be true for most of the functions we see in this class, then the derivative of the sum of the two functions is equal to the sum of the two derivatives calculated separately. Let's look at this very carefully in this box here. First, I have the differential operator d on dx applied to the quantity f of x plus g of x. Now, I'm saying these things very carefully to help distinguish the one side of the equation from the other. This is supposed to be equal to the differential operator d on dx applied to f of x plus the differential operator d on dx applied to g of x. So on the left side, I'm saying add the two functions first, then calculate the derivative, because my parentheses are the first order of operation. On the second one, I'm saying calculate those derivatives separately, then add the results together. Now, this extends very nicely. So if we had the sum of three different functions, let's say I have quantity f plus g plus h all together, and I'm taking the derivative of that, so I've got that with a prime symbol there. Well, I can group these and call this f plus g quantity plus h. So then my derivative should be equal to the derivative of quantity f plus g plus h prime, but I already know that my parentheses here will behave according to the sum rule. So I'll get f prime plus g prime plus h prime. The short of it being, it doesn't matter how many plus signs I've got, my derivative will spread out across all of them in the same way. Now, we can do a little bit better than this. If I combine this idea with my constant multiple rule, then I can also treat the difference of two different functions. Let's say I'm calculating d on dx of the quantity f of x minus g of x. Well, the derivative of a negative g of x is minus the derivative of an ordinary g of x. So the derivative of the difference of two functions can be calculated as the derivative of the first function minus the derivative of the second. So, just like derivatives can break up over plus signs, they can also break up over minus signs. How lovely. Let's actually calculate some of these in just a moment.